Bismillahirrahmanirrahim. Assalamu alaikum. Today I will be discussing how to do mechanistic analysis of a rigid pavement using CAN-SLAB module of CAN-PAVE software. To start with, I have defined a simple problem in which I have to analyze a 3-axle truck that has got an easel factor of 10.84, and for that the following pavement is recommended. I pardon, this is a 4-axle truck that I'm analyzing. The following pavement is recommended. It has a PCC of 12 inch. It has a combined, actually this section has got 12-inch aggregate base. It has got improved subgrade 50 of CBR 15 and a CBR. So for that, we'll have a combined CBR beneath the 12-inch PCC pavement is 24,320. The pavement is a rigid pavement, so it has been designed for 20 years, and the modulus of rupture is 530 psi. As per Green Book, this truck that I have defined is also known as wheelbase 40. As can be shown here. So for those of you who are very novice to this pavement design and nomenclature, there are some things that you need to understand. The first wheel is the first, the set of wheel, or the first axle is known as steering axle, and it is abbreviated as SA in my analysis. The second axle is known as the middle axle, and the third axle is a rear axle or drive axle, right? We call this as a trailer axle as well. For this truck, in CAN-PAVE, we analyze this in two parts. One, we analyze the pavement between these two axles, and we also analyzed pavement between these two axles. And it is very necessary if you are analyzing the pavement for in this way, because for a vehicle in this way, because it do happen that the pavement between the first two axles may not be same the pavement between the other two axles. For example, here the pavement may be different for steering axle and the middle axle, and this. So what we can do, we can have a different scenarios for that, and that we will discuss at the end of this, actually towards the end of this lecture. So let's see what are the let's summarize what are the dimension, and before we'll use this Excel sheet, and it's like this. that this is a WB40 vehicle. It has a width of 8 feet. This dimension I have taken from the green book, the S2 policy on geometric design of highway. The length of the vehicle is 45.5. In CanPave, we need this in inches. So whatever I have done, I've converted whatever the dimension I have converted it here. The center to the center of the wheelbase one is 12.5. As I can see from this diagram, this is the 12.5 feet. And so the distance between these two wheelbase is 150. But in CanPave, uh, you can you are interested in the internal dimensions. So the distance between the uh, the first wheel at the end of the first wheel and the start of the uh, second axle. That is, I am interested here in the distance from the end of this first wheel to the uh, distance here. So I can say that if I subtract the wheel dimension, which is 3.3 foot, that is shown. So I will have an internal dimension. So what I have done here is the same thing that I have subtracted from 12.5 1 times 3.3. So I become it. So the distance between the steering axle and the middle axle is 110 feet, 110 inches, I guess, to be precise. Now, we are also interested in analyzing the medial and rear axle. So that's how we'll calculate the distance. In the similar manner, I have got 238 inches. Now, the second step, I will need to know the load on each axle of the truck. For the truck in Pakistan, the National Highway Authority allows 39.5 gross ton of this type of truck. So that's why I have taken this 39.5 ton and if I convert into pound, this is 87,710 pound. And then I will calculate the load on each of the axle, the steering axle, the middle axle, and the rear axle. And as per literature, 14% of the load is on the steering axle. That's why it's 12.29. 30% of the load is on the middle axle. So that's what I've done. 30% of 87,710 make is 27,000, 26,313. And 56% on the rear axle. That's why it's 49,137 pounds. Now, uh, uh, in mechanistic analysis, we are interested on the load on the wheel, and the steering axle has two wheels. What I've done is divide 12.279 by 2. And this middle axle has 4 wheels. That's why I have divided this 26,000 by 4. So I've got around 6,500 pounds. The load is in the pounds as well. The unit are in pounds, right? And the last one has an 8 wheel. That's why this has got 6,140 pound on each of the wheel. Ironically, the study shows the normal tire pressure on the front axle of the trucks that are being operating on the national highways of Pakistan has got a normal pressure of 120 psi on the front axle or the steering axle and 140 psi on the middle and the rear axle. Now, if I'm interested in knowing the contact area, because I'm doing the mechanistic analysis, so what I need to do is to divide this load by the tire pressure. So that I've got 51 is the contact area for wheel 1 and 2, wheel 3 and 6, 6, 5, 7, 8 divided by 140. And for the rest of the wheel, I'm sorry, this is not 5, this is 7. 7 to 14, we have got 44 square inch. Now, the, the tire pressure has this area. Uh, it's, uh, it is assumed that while for a rigid pavement, a single tire on the pavement has this, you see, ellipsoid shape impression. So what we need to know is to know the length, and to calculate length, we divide AC, area of contact area, divided by 0.5227. And the calculations are very simple and is shown in your book, textbook, chapter 1 of the textbook as well. Even though we have this area of it's a third circular area per rectangular, you say this is one half circle, this is half circle. So, but we again assume it is a rectangle area. So the length of this tire is 0.8712 L and 0.6 L. That's why here I've calculated the length as 10, 9, and 9 by using, first I've calculated the impression of the tire, and then I calculate that means length of each of the tire configuration, and then I've calculated the length and width of each of the rectangular area, uh, this one and this one, for each of the tire that I need to analyze for my pavement. So once I have done this, I also know that the distance between my dual tire is 14 inch. What I mean is, let me show here. So the distance between the dual tire is 14 inch, while the distance between on those sides between the axles, between axle is 48 inch, and the tire that will be on the inside of the page, that is, there is a wheel here and there is a wheel behind, and it has got sometimes a 12 inch, maybe 14 inch, some kind 16 inch. So I'm taking this 14 inch. So it's a distance between the two tire on an axle. So what I'm trying to say here is that the tire distance between the two tire is 14 inches and the distance between axle is 14 inches, right? Now, let's analyze the first two wheel for which I have to know, for which I have got, I have required in the can pave the load group. So I'll analyze it separately between the steer axle and middle axle. So what I'm going to, I'm trying to mark the dimension so that it can be plotted on my can pave. So can pave know what is the exact location of these tires on the pavement. So the first one is the origin. So we'll have actually what you do. Let me show you that the can pave wand. So this is my tire. So what I need to know to define each tire, I have to give dimension of this corner and the dimension at this corner. So on the first axle, as you know, on the steering axle, we have two tires along the width. So what I've done, these are tire 1 and tire 2, and there is only one slab. That's why it's these these are on slab 1. It may have multiple slab, but we are analyzing only one slab here, and that is by only PCC. So obviously, the first point here will be 0, 0. That's why x0, y0. And the second point here will be 9 and 5.94 for the first tire. So this 9 and this 5.94. Now, the second tire along the width is this tire. Obviously, there is no change in x-axis, but there is a change in y-axis because we have moved this distance. The truck width is 96 inches. Total width, as we know from our dimension. So all what I need to know is to subtract this much of width. So what I'm going to do, so the first point will be my 0 and 90 because this is 5.94. So let's see, I've taken as 6 to 4 for is, simple calculation purpose to explain here. So that's why 96 minus 5.94 is 90. So my first point will be here 0 to 90. And the next point will be 9 and 96. That's why. So this is 9 and this is 96. This is the coordinate of this wheel. So I've defined the first two tires of the truck. Now, what I'm trying to do and explain here is, so what I'm going to do, then I will have, this is my steering axle. Actually, will have these are the four wheel I have on the rear axle. The distance between these two axles, these two wheel I have calculated as 110. I told you that the distance between these two wheel is 14. So what I am going to do is now define this third wheel. Again, the third wheel will be the first point along the third wheel will be this point. This is 110. And it is sitting at y1, that is 0. The next point will be 110, 119 here. And for y, this is the width of the tire. And that for the second tire, we have calculated as 5.69. Actually, when we rounded it 6, so just say, so this coordinate will be 0 and 5.69 or 6, you can say. Right? Now, just try to round this as well so that there's no confusion. So this will be my third wheel. The fourth wheel will be again here. Start point will be same, x1, and the end point for x2 will be same. But what has happened is equal to this. So this is this, but this is the distance between, for defining this tire, 0, this 110 and 14. And the other side will be 109 and 20 because I have to add from this is the 14 and then I have to add 6 that. Sorry about the exaggeration on the vertical axis, right? Right. This is not to scale tire actually. Now I have defined this 2 tire. I will go for this tire. Now the distance, all of this distance is 96 because the truck, this wheel cannot go more beyond this tire. So it's easier to first define this tire. So again, the x-axis dimension of x is not going to change. All is will be changed in the dimension of 96. The y-axis. So what I've done, I've taken this 96 and I subtract 96 so that I'll be at this point, right? And for this we have 110 and 90, and this point is 119, 96. Then what I've done, I've subtracted, come below, I've subtracted 14 here and 16, further 6 here. So my distance is now 71. So my first point is 110 and 71. The other point is 110 and 76 for obvious reasons. So this is how I have defined. In a rigid pavement can pave slab, we have to make the grids, and for that we have to define the grid size. Mind you, the ratio between the x-axis and y-axis should not be more than 2. Maybe 2.5 sometimes enough, but it doesn't take more than 3, and sometime the limit is actually 5, but it's the more the it is try to have the square grid as close uh, as possible. But if you can have a smaller ratio like 2 and 2.5 between x and 5, it will also be good. So for that, you have to know what is the lowest point and what the highest point. My lowest point in this analysis is 0, as I can say. The highest point is 110. So for the time being, I've taken more than that. And on the y-axis, this lowest point is 0, and the highest point is 96. So even though I can have this nodes here, but I've taken this more. Another thing you will need to know, and very important, is the total number of load repetition. And this is defined by truck factor into 20 into 365. So what I've done is I've defined this here as well. And now I'm going to define all those things. And I will try to define you what should be, how we should open this campaign. But I'm not experimenting very much, but I will tell you how to go to different menu and use these Excel values over there. So let's start the CanPave software. For that, we'll start this window, CanPave, and we are talking about this slab interval, this module. This is Can slab. So first I'm going to say slabs input. And since I have already defined a file for you, I will go for the old and I'll open this analysis in which I've taken WB40 truck video front to middle axle analysis, and say I'll open it. General, I have since I have to choose damage analysis, so I have a solid foundation, that's why 1. We need to do damage analysis, that's why we have 1. Since I don't have any user, I'm defining using the PCA criteria that is already be defined by the software. I'm taking only 1 year at a time. So that's why number of period. That's why number of load repetition was for 1 day. Number of load group is two because there were two groups of axle, the first two axle. The number of slab layers is one, and the number of slab one, and then this always there is number of node for sheet, print out for damage analysis three. Um, we will talk about with uniform load, and we are not going to analyze this for any of the thing. It's better to not to do it. If you have to do it for temperature curling, don't do it for uniform load. So this is you know such a thing in the software. Most of the time, we are not interested in temperature curling. We are interested in how it behaves from the external load due to to the trucks rather than the temperature. Then we will go and we'll say, okay, there's nothing we have to change except this foundation one, damage analysis one, and the NLG two, one and number of print. These are the values that normally we change. Otherwise, all the default values. And then with the uniform load, that's okay for us. And for that, I'm sorry, we say this is we are analysis WB40 CRC pavement between the first and between, I can say, the steering axle and the rear axle. That's okay for us. And then we'll now not going to do anything for that. For slab, we'll come here. We need to do arrangement. We'll say there will be 9 nodal points, X and Y. How? This is I have defined. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9 nodal point I have defined here. Right? And then what I'm going to do is I'll say okay. And then I will know X coordinates. So I'll say 0, 20, 40, 60, 80, 120, 140, 160. Okay. And then I will say for the y-axis, this is 0, 15, 96 I want to take because I'm interested in knowing the exact location of the wheel. Okay, I'll say. Then the properties of the slab, I say, even though, let's see where I was given a 12, to take this 12 and see what happens. Poisson ratio for concrete we know is 0.15 and the Young model is 400, 4 million. That's why it's written over here. So that's okay. And that's done. Now we'll go to uniform load. The first one, I've drawn this for you as well, has two rectangles. That's why it says NUDL2. The second group is 4 rectangles. That's why I have defined 1, 2, 3, 4. For defining the load, I have calculated NUDL LS1 0 to 8.61, 0 to 5.9. That's what I have defined at what is the tire pressure here. So that actually I have calculated in Perform Excel sheet. I just have to input. And for NUDL is similar like that. I have calculated where I have just write. And just maybe a small, uh, approximation. But what you need to do once you have calculated, you have to directly input the data once you have calculated an Excel sheet, and you have to put it here. So no much issue here. And we say okay. And then for the optional data, we have to put this optional data. We always are interested in, this is default 1937 nodal points. And then for Y symmetry, we just write 1, 2, 3, 4, 5, 6, 7, 8, 9. That's it. Okay. Then get out of this menu. And then I'll go to the foundation. This is the young voltage that has been given to us, and the post-hard ratio of subgrade is 0.4. That's why I've written over here. Okay. And then I do the damage analysis. For that, I need the MOR 530 that was given to us. So that I've said 530. And then the volume of the traffic that I've calculated around 79,132 that I've shown here as well. Okay. Okay. Then okay. Then I'll save it. Okay. Then I'll exit from it. And once I exit from it, I'll have to run this CAN module and see what happens. It says depth is not okay or it is over designed. What we can do is to again open the file that we have created, and then we go to the file first. And now we need to do is, for optimization, just we need to change the value of the thickness. So let's see what about say 9. Let's see, or maybe 8.5. So we'll go there. Okay, we'll go okay. We'll save it. We exit it, and then we run the cancel. Now it says 2.75. So this would mean that the slab is under design, or the pavement is under design. It will only last for 2.75 years, meaning that we need to go increase the depth more. So again, we'll open that file. We want to understand, we want to remember where is that file open, and then we'll go to the slab once again, go to the property and say 9. See what happens. Okay. Save, exit. 76.99. Because this is the first trail, we don't know what will be the analysis of the second lab. So let's take this as 9.5 years, 9.5 inches as a thickness, and then analyze the second portion of the problem, that is the analysis between the middle and the rear axle of the truck. What I mean is to analyze between these two axes. For that, we have to create a table, the load table, because there are 4 wheels on the rear axle and 8 wheels on the middle axle. We will assume this as 0s. That's why the first one is 0. And then the distance between these two axes is 238, as we have calculated here. So what we have done here is just find those values, find those locations of a triangle of a rectangle for the load analysis. And then what we need to do is again go to CANPAVE, slabs input. Since I've already created that file, so then I will go, that's the distance between middle and rear, the analysis, open. We don't need to do much. We already had just change the coordinates of x, because now The 294 is the maximum distance, as I can see over here. So we'll say OK. And for that, X, I've increased the grade from 0 to 300. And similarly, the grade Y coordinates is this. OK. I have, kept, because my initial question was 12. So I just keep this as 12. And rest I'm not going to change. Okay. Then the uniform load I have to change. Now this is the first axle has 4 wheels. That's 4. The rear axle has 8 wheels. That's why 8. And then obviously I have to input all those values that I have calculated from in Excel, already in Excel. So what I'm going to do is not to do much. I just input those values here for the first one and for the second one, like this, 8 wheels. Okay. And then, okay. And there's nothing I will have to do here. Actually, in fact, you have need to copy the first file, to save the first file, and then you just have to change the coordinates of the loads. That's all you need to do. Then go to exit and say, yes, I want to change this file. Okay. I'll go and run cancel app. And I find the design life is 12.73. Remember, I need to have a design life of 20 years at least. What happened there in the first analysis, we have found 9.5. Now, here in the second analysis, we found even 12 is not okay. So obviously, what we need to do in such a type of problem, we'll go to axle by axle and then we'll get the maximum value out of this, and we have the design. We'll design the pavement for such thing. Okay. Then I'll go and I'll try to increase, because I've been asked, I have to optimize my design, and this will be slab, and the property is 12.5. I'm sorry, it's 12.5. Okay, I don't have to do much from anything else now. I'll save as it is right now. Just exit, I'll not cancel it, and I find 36.5. So that's it. No, I can just, I could have tried 12.25 as well, but it's 12.5 is okay. Just look at this S graph to see where the wheels are located. You can see the first 4 wheels, and then this the 8 wheels that I've analyzed. So that's my geometry, and in between that, note if this design life is the 1000 years, it is not going to be displayed. But if the design life is less than this, your design life will be printed as here as well. And that's the thing we do, and we say yes. And then we go to printing, and we can, from editor, we can go and open that file. Open that file first. This is middleware. It's a TXT file, and you know your analysis, and this design life 36.5. So that's it. I hope that I was able to communicate well the software, especially the mechanistic part or the damage analysis. Thank you very much for watching. Take care.